One thing you can observe from this application code is the area of a shape is actually meaningless. You should never ever call it in any meaningful application. Only area from rectangle or circles are meaningful. But I have called the get area from shape only for testing purposes. So let me comment that part out, the area of a shape, and give area variable declaration here. Then area of a shape is actually meaningless. So let me comment that out. Then I'm not using shape of area of a shape directly. So let me compile. Program all works fine. Since my observation is I'm never using area of a shape, so let's take that get area function out from shape because it's never actually ever used. So comment out. And then let's see what happens. To show that, let me just eliminate any those compiled code already, and let me give a fresh new compilation. Then what it says is that main function line 34 sp arrow get area is error. Error is no member named get area in shape. So compiler looks for get area function in shape class. So main function line 34, I used this line to explain dynamic binding that is not based on the type of SP, which is shape, but based on the value in SP, which is a circle. So get area from circle is called. So that's a idea or concept of a dynamic binding. So area of a shape is never used, but compiler says it's looking for get area in shape. So what is happening here? So we need to understanding binding in C++ in many similar high-level languages. We have two bindings at compile time, so that is here, and at runtime. Two binding happens. So what we have studied is a dynamic binding at runtime. When you run the program, dynamic binding says not based on the type of SP, but based on the type of the value in SP, get area is called. However, before you run the program, you should compile it. So that's called the static binding. Static binding means a compiler looks for this name, get area, from the type of the variable. Just straightforward. The SP is a shape type, then compiler looks for get area from shape class. If there's no such get area in shape class, you have a compiler. So that's a static binding compilation. Once it's compiled, we never use it though, but to avoid the compiler, we have to give a get area function in shape to avoid the compile error. So that sounds a little bit weird though, but that's a requirement in C++. So what you need to do is we need to give those back. That's required. However, you find that giving this kind of a dummy implementation is not very professional code. So do we have a mechanism in C++ to eliminate to this kind of a very unprofessional code? Yes, that is a pure virtual function implementation. So you don't need to give implementation of get area at all. In that case, you need to define this get area function is a pure virtual function by giving equal 0. That's a pure virtual function declaration. This is a virtual function when you give a keyword virtual. We have explored that already, but if you give equal 0, then it's called a pure virtual function. Pure virtual function is you do not use implementation of a get area at all in actual implementation code. So I don't give this implementation at all. But to avoid the compile time error, compiler in main.cpp looks for get area from SP shape type. Then if you declare get area is a pure virtual function, then compiler is satisfied with that. Then just continues a compilation. So pure virtual functions are for that purpose. Now let's compile the program. Clear the screen, compile. But still it has some problem. First, the very first is line 18 of a main. Variable type shape is in abstract class. Now here is a new terminology. Abstract class means a class which has at least one pure virtual function that is called abstract function. So abstract class cannot instantiate an object. You cannot define variable if class is abstract class. The real life analogy is get area is not clearly defined. It only name is given as a pure virtual function, but implementation not given. When you construct a house, the internal structure is not defined, then you cannot build a house at all. Something like that. So if a class has a pure virtual function, then you cannot create a structure, a variable out of that. That's a violation. So you should never ever create a object or variable of S1 class. That's what the error message says. So let's go to the main.cpp. Any variable of a shape here, I need to eliminate it there, and then S1 is a shape variable, so I cannot call that. Also, new shape is creating shape variable or object, so it is not allowed. So let's just comment this part out since SP is used. But pointer declaration is not object. Pointer is not an object, so pointer declaration is allowed there, and then continues there. The array of pointers is not a shape object itself yet, so this is allowed like that. So now let's compile the program again. Then all program is correctly compiled, and then it should run fine, exactly the same. It works. So pure virtual function, then class becomes abstract class. Then you cannot create object of shape, but you can define pointers. Then using pointers, you could use polymorphism based on dynamic binding, and then you can have this kind of very powerful programming so that you don't need to distinguish in your code which type you are dealing with. Using dynamic binding, you can just write one same code to do differently when program runs. That's a power of polymorphism.